Hello! It's Exploding Chemistry Time by Teacher Susan. What are we going to look at today is metallic bond. What is metallic bond? It is a chemical bond that arises from the electrostatic attraction force between conduction electrons and also positively charged metal ion. Well, metals are the only substance that can conduct electricity even in solid state. Why? Because they are having mobile electrons, or in the other way, we call them as free-moving ions. According to the X-ray analysis, this is what you can see on your screen, your left-hand side on your screen. The red color small dot is actually representing the electrons. And you will see that there will be a lot of red dots accumulated around the cation in the column at the bottom of your diagram. So what is this? This electron basically belongs to the valence electron of each metal substance. When this valence electron moving here and there, ke sana, ke sini, ke sana, ke sini, like that, it is going to cause the particular metal atom will turn into a cation temporarily. When we attach this metal into a circuit, and when the circuit is complete, the electron from the metal, it is going to flow in a direction. So they will be attracted to the positive terminal of the battery and releasing out again from the negative terminal of a battery, thus returning into the metal substance. And the flowing of this electron throughout the circuit, non-stop, continuously, it is going to cause the conductivity of electricity. As you can see, the valence electron in all these metal substance, they are located in the outermost shell. This valence electron is able to move freely throughout the crystal. They will step out from its own valence electron shell from the first metal atom, and they are going to go traveling into the second metallic atom onto the outermost electron shell. So when they do this, moving in and out, ke sana, ke sini, ke sana, ke sini, so this is going to cause a situation that we call them as delocalized electron. And when we have a lot of delocalized electron, we classify them as a sea of electron, satu ombak electron. Okay, you can see the ombak like flipping bush like that from one direction to another direction. So this sea of electrons basically representing the mobile electrons that moving here and there, ke sana, ke sini, ke sana, ke sini, and normally their moving direction will focus from the movement until they move until the positive terminal of a battery. And that circuit repeat again and again. So this is how we conduct electricity from a metal substance. Okay, to make you understand more on how the formation of the metallic bond, today I'm going to use magnesium. So there are few points that you have to focus on in your essay writing regarding the formation of metallic bond. So first of all, when you are given magnesium, your main job is to identify the valence electron from your magnesium. So sentence number 1, we have to mention that magnesium atom, the keyword atom is important. Magnesium atom has 2 valence electrons. And these 2 valence electrons is actually belongs to unpaired electron. Okay, when they are pairing up, they should achieve octet or doublet electron arrangement. So what happened to these unpaired electrons? Now second sentence, in a solid phase, the valence electron that we mentioned previously, which is the unpaired electron, for each magnesium atom, they can overlap each other. You on top of me, I on top of you. They are like playing gusti like that. So they are doing overlapping among each other. And once they do overlapping, they are going to form into a giant molecular orbital. Okay, when these valence electrons of each magnesium moving freely and delocalized throughout the whole crystal structure, basically they are carrying some charges. So when this valence electron moving away from its atom, temporarily this atom will have a situation whereby cation is formed. Imagine that in a magnesium, we are having 12 protons and 12 electrons in the same time. However, two of these electrons, naughty boy, they kesana, kesini, and they're going out from the atom. So what happened? Inside the nucleus of this magnesium remain 12 protons. But around the nucleus, there are only 10 electrons. So at that moment, this magnesium atom will automatically convert into cation. When there is a cation, this cation will try to pull the delocalized electron towards them. So when they are doing the pulling, tug-of-war kind of effect, so that effect eventually causing the formation of metallic bond. Okay, understand that? Well, after we talk about how to form metallic bond in a metal, we also need to study there are a few factors eventually can help us affecting the strength of metallic bond. We can have many different type of metal, but when we are doing a comparison, we will find out that why different metal, the strength of the metallic bond are different. Some are quite soft. I can just bang, bend it and it will break. But some, you hit on the wall, you hit on your head, you hit on your leg, it is still remain sturdy and hard. So what are the factors affecting the strength of the metallic bond? Well, let me tell you, there are 3 factors that can affect the strength of the metallic bond. Number 1, it is the number of protons. When this element, this metallic element has more proton in the nucleus, therefore they are going to have a stronger electrostatic force towards the electron valence at the outermost shell of the electron. So when they are having a stronger electrostatic force, indirectly the strength of the metallic bond increases. But number 2, the number of delocalized electron per atom. Every single atom, they have their own number of electron. So when we are looking at the word delocalized electron, we are actually referring to the valence electron. If you and I, you have 1 valence electron and I have 2 valence electron, the more valence electron that I have, I am going to form a stronger electrostatic force. When I am able to form a stronger electrostatic force, confirm my metallic bond that formed within me will be stronger than you because I have 2 valence electrons and you only have 1. Number 3, it refers to the size of ions. Imagine that, okay? Imagine that if I give you sodium and potassium, after these delocalized electron moving here and there, so what happened is that the ion size for sodium is obviously smaller than potassium. When the size is smaller, the distance between the nucleus with the valence electron basically is nearer. When it is nearer, one time the neutron said, "Oi, come back here, if not you are going to die." Immediately, this delocalized electron will be attracted back to the nucleus. And because of that, the strength between the nucleus and also the valence electron is so high, and it is going to cause the stronger metallic bond if the ion size is smaller. Alright? Clear? Next, we give you another example. Let me drink some water first. Now this example, we are going to look into the comparison between the melting point of magnesium and sodium. Why magnesium will have higher melting point compared to sodium? So first, bear in your mind, sodium is in group 1, magnesium is in group 2. Okay, they are all belongs to period number 3. So if I look into the electron arrangement of sodium, it is 2 at 1. Magnesium, 2 at 2. Indirectly, I can see that magnesium will have more delocalized electron compared to sodium. Okay, that's why if you see my point 1, we will look into the proton number. From the proton number, we can know that magnesium is actually having more proton than sodium. So factors number 1 comes in. When the number of the proton increases, electrostatic force between the cation and the delocalized electron will become stronger. Because when you have more proton, automatically your delocalized electron must be higher. Just that your delocalized electron is naughty. They go in and out, sana sini like that. So therefore, when the moment nucleus say, "Oi, come back to mommy here," all the naughty boy have no say. They must come back to their mommy. So that causing the strength of the electrostatic force to be very strong. The moment when you have a stronger electrostatic force, indirectly, the metallic bond is strong. In order for you to break the metallic bond, you need to absorb a lot more heat energy. So this a lot more heat energy that absorb, eventually, it is going to increase the thermometer reading from room temperature into something else higher. You can see from the rise of the mercury. So because of that, this show the melting point of magnesium basically is higher than sodium. Well, just now the example we are doing comparison for the boiling point between two elements of two different groups. Now let's us use an example for two elements, but they belong to the same group. Both of them are group 1. So we have sodium and we have potassium. When they are in the group 1, they only have one valence electron each. So meaning to say the delocalized electron number is the same. So now what make them have difference in terms of the strength of metallic bond? So what we can see here is the size of the ion. Imagine that both your sodium and potassium, every one of them is going to release out one valence electron. The only delocalized electron that going out far away from the atom because they kesana, kesini. So when these valence electron going away from the atom, both atoms will eventually turn themselves into cation. While when we do a comparison between the cation of sodium and the cation of potassium, obviously the size of sodium is always smaller than potassium because she has 2 shells while potassium ion has 3 shells. When the size of the ion is smaller, the electrostatic force between the electron on sodium ion as well as the proton in the nucleus of sodium, it will be stronger because the distance quite near, right? So they will be having a stronger electrostatic force compared to the potassium. So at that moment, when this sodium ion shouting to the valence electron, to the delocalized electron, "Oi, come back here." So this is more powerful to attract the ion to come back, and thus the metallic bond that is formed between sodium is a lot stronger than potassium. So when the metallic bond is strong, obviously more heat is needed to overcome the strong force, to break the chemical bond, to break the metallic bond. So this is why, when the size of the atom is smaller, they are having a higher and stronger metallic bond. Okay? Well, I also feel like my mouth will blah 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 like that already after giving you guys so many explanations. I hope that you can follow and can understand the explanation that I try to explain to you. Now, before you proceed on, we must always do a test on you. There are questions on the checkpoint, and don't worry, the answer is prepared for you. Be honest to yourself. Look at the question 1, 2, and 3. Try to refresh back. What have you learned from me? Try to put down your own sentence according to your own understanding. Then only you open up the lower column to check the answer that provide to you. Remember, when you see the answer is being highlighted in red or yellow color, they always means that this is very important. Never neglect us. See? If you don't have the proper keyword, you are not going to get a good grade. Trust me. Keyword is very important in answering your SPM. You like it or you don't like it, you have to fix on to your keyword. Trust me for that. Alright, after you have completed your checkpoint, correct your brain cells, squeeze out all your brain juice to finally find out that whether you understand or not understand certain part under metallic bond. But before that, that is not the end of the world yet. You need to do some enhancement. Then only you can turn yourself from nothing become Albert Einstein. Follow the 2 red book that I recommend to you. It is a very simple guided questions. Complete it before you can go to sleep. Alright? Make sure you do those questions in your workbook. As people say, sikit-sikit lama-lama menjadi bukit. Kalau sikit-sikit pun tidak ada, tidak payahlah kau tidur di rumah saja. Nah, I believe everybody of you will be very happy. This is the slide that you always want to see. Okay? Thank you for your watching. Thank you for your attention. Now you feel that, wow, I can get away from the gripping, from this exploding chemistry teacher. She always make us learn a lot, study a lot, forcing us to do a lot of homework. Yeah. That's me. Alright? If you know me well, you should know that's me. Well, before that, before I can end my slide, my sharing today, Again, please remember to do your revision. Always remember that I can give you knowledge, but if you don't earn your knowledge yourself, you are nothing. Well, before you end this slide, you log out from this slide. Okay, you get away, go to far away, local traveling. Please remember your teacher's word. Always help her by sharing her video. Give her a big like in her video. Give her comment. Okay, and lastly, not forget, must subscribe her YouTube channel. Hit on to the notification bell because more and more advanced and helpful video will approaching you to help you, to accompany you until your SBM. So this is my last word, but I'm not yet dying. Alright, see you guys soon. Bye bye.